Hello everybody and welcome back. So this lesson is going to be pretty intense. This and the next lesson we're going to cover a topic that when I first learned Python took me quite a long time to wrap my head around. It's not that the individual methods are overly complicated, but just sort of how each class interacts with the subclasses and how you need to move data from one to the other and reconstruct it is just, sometimes it takes a while for it to really sink in. And sometimes it can sort of seem very confusing, especially the help file, as good as it is, doesn't really, sometimes it even confuses you more than you thought until once it starts to make sense, then you can actually see what the help file is saying. So there's a lot of moving pieces here, which is why I want to break this down really in detail. We're going to go through each step. We're going to do a good example of how to manipulate these parameters, because I want you to understand this, and I don't want any of you to struggle like I had to actually learn this from scratch. Okay, so what I'm talking about is creating and manipulating parameters using Python. Right? Now this is one of those things where I said once you understand how Python works with Houdini to do this, it actually gives you a greater sense of how Houdini itself is built from the ground up. Kind of like popping open the hood of your car, you can actually, poke around and actually learn how the car works. And then when you're driving it, it actually helps your driving because maybe you hear a certain sound or you can feel certain things. And because you understand the engine, you know how better to use the vehicle. So that's kind of what we're going to do here. Now, because I want us to have something practical for this to actually be able to sink in, we're going to kind of, as we go along, put these into practice. And in order to do that, we're going to need to create an HDA for ourselves. And then we're going to use an HDA and then a normal geometry node as kind of two examples, practice examples, like test dummies, to test these different things on. Okay. Now, I specifically want you to create an HDA from scratch, not one that you maybe already have, because if we do this wrong, we can actually break the HDA because we are literally altering the definition through code, and that can be a little bit kind of dodgy if you don't do it right. Okay. So before we even get going with the lesson, let's just create our two test dummies. So we're going to drop down the geometry node and just publish this. So right click, create digital asset, and then we can go and give it a name. So I'm going to literally call this one test dummy. Okay. And I want to save it instead of just to my default library over here. I'm actually going to save it to that working directory that I showed you guys way in the beginning of the course, which is where we're going to save sort of global HDAs. Okay, so I like to work out of a more global location for my HDAs. Right. So in this folder, which is where we're going to be creating our HDAs later on in the project, I'm now going to also create this, and I'm just going to name this asset test dummy as well, testdummy.hda. Okay. So if we say accept and destroy all spare parameters and say accept, we should now have a test dummy asset, which for all intents and purposes is identical to a geometry node because we literally just published a geometry node. But it's important that we have one that is a non-published default asset node of Houdini, and then one that is an actual published HDA. So if we type test dummy, you'll see that we have that here and we can drop it down. Okay. So now, in fact, I'm going to even label these so that we can see. So that's our HDA, and then this is our node, our normal node. Okay. So once you've done that, then we can kind of pick this apart and see what we're going to do. Now, ultimately, what we're focusing on is these parameters. So everything on top, when we select it and we look at this parameter sheet, everything here is what we're looking at. Now, what we see is folders. We've got actual parameters, so palm tuples like our T and R. and then the individual parameters within that, so X, Y, Z for each of these. And we've got all the different types, so we've got drop-down menus, we've got floats and integers, strings with presets, all of this, toggles, everything, okay? Including toggles, when we toggle that on, it's now got hidden parameters, right? Everything that we're able to sort of manipulate and change here is what we're looking at changing, but using Python, okay? Now you can sort of understand why this gets so complicated, because there really are a million sort of moving parts to this, okay? So let's first try and discuss how Houdini actually works a little bit, and how we can sort of manually, without Python, how we create parameters and sort of our parameter templates. And then we're going to sort of work backwards from there to see how Python works with it. Okay, so when we take a node that's not published and we want to alter the parameters, where do we go? Right? We don't right click and go anywhere down here like for type properties, because these parameters over here, you'll find there are no parameters in this list, okay, under type properties. That's because this is not published. But on the parameter sheet, if we go to the cog here and go to edit parameter interface, then we can alter parameters here. Okay, so we have a list of parameters, which is very important to understand. There's a list of parameters, and on the left hand side we have a list of templates, right? So nodes or parameters that we can drop in, drag and drop in, and they each follow a certain kind of template. We can drag in a normal float, or a float vector 2, vector 3, or vector 4. We can drop folders, toggles, down here, strings. Okay, there are all of these, including even separators, right? So we've got a list of templates and a list of actual nodes. These nodes are all a copy of one of those templates, but with some parameters changed. And these parameters, or these sort of settings on the right hand side, determine how this one parameter operates, okay, including its defaults, the size of it. So, you know, is it just a single float, or is it 3 float vector? Does it have a callback script? Is it hidden? All these tags, the help file, everything, literally everything we're seeing here right now in this floating window, we are going to be able to do and change through Python. Okay. So any parameters that we create now, let's say on our normal geometry node, I just want to create a float. So I drag a float parameter in and just say accept. What I've done in this here is I've created a spare parameter. Okay. If you ever see, like when we created this HDA and it asks us what we want to do with the spare parameters, and we said destroy all spare parameters, right? That's what this means. So if I had to create this spare parameter and now publish this, it would ask me, okay, do I want to keep this spare parameter, or do I want to kind of copy it into my template, or destroy all of them, right? So it's important to know the difference between spare parameters and then actual HDA parameters. Okay. Now, on our normal node, before we publish, there are some that are technically kind of halfway between spare parameters and HDA parameters, because they appear here in the Palm template, the parameter interface window, like spare parameters do, but we cannot edit them because they are kind of part of this published node, right? This default node. So it sort of operates like an HDA, except they appear here in this list of spare parameters, okay? So although they are not technically spare, we can kind of work with them like they are. On the other hand, when we move to an HDA, it changes a little. If we go to our edit parameter interface over here, you'll see that, first of all, we cannot see the, like if we go here, let's say we go and add float. Okay, so we're going to add this to our HDA through this method. This is adding a spare parameter, right? Exactly the same as what we just did on this node. We can add a spare parameter over here. Now, when we go to, if we right click and go to type properties, this is where we see our actual HDA definition parameters. Now something you're going to notice is that we cannot see our float. So this new one, which we called parm, it doesn't appear in this list. And why is that? So it's not that it's actually technically even there but invisible or whatever. What's important to understand, a very clear distinction that I want to make right now, is that what we're looking at in this window, although it looks very similar to when we go to edit parameter interface, these two windows look almost identical, and yet they couldn't be more different. The sort of functionality is the same in that there's templates, list of parameters, and then details of those parameters. But what we're looking at here is not the parameters on our node. We're looking at the parameters of the definition that is stored on file. So when we navigate here, and on disk there is a file here called test_dummy_HDA. And when I'm looking at these parameters, these are the ones that are on that file, that original file. So remember when we spoke about classes, Python classes, where you make a class, for example, humans, like a human being in general, right, is a class. But then an individual human is an instance of that class. It inherits all the same kind of global properties, but then has its own altered versions of those properties. Okay, so humans will have 2 eyes and 2 ears and a mouth, but your eyes might be a different color to another human being. So you are an individual instance of that class. Well, that's essentially what's happening here as well. HDAs have a definition which defines what that tool kind of looks like and functions like. But you really cannot actually import an HDA into your scene. What you can import is an instance of an HDA. So HDA files just live on disk. They are just a definition that is a theoretical kind of perfect template of what this tool should be. But when you create one in your scene, you now have an instance, a copy of that perfect template. But now we can go and alter it. So we have altered it, and we've gone and added in an extra parameter to this, similar to maybe a human being, putting on a hat. Okay, so not all human beings inherently come with a hat, but now this one human being has added this additional appendage, this additional thing to themselves, right? It can be removed, it can be altered, some can have them, some cannot. But the template itself has not changed. When you put on a hat, you don't change your DNA so that all human beings suddenly have hats, right? So you need to think of it as this is the individual, and then when we go to type properties, this here is the kind of the sort of map or blueprint of what the HDA should be. Okay, so very important to understand the difference between those two, because when we start changing parameters, we need to decide whether we're wanting to change parameters on the definition or whether we want to change parameters on the node itself. Okay, and those will result in two very different methods of how we work with parameters. Okay, so what we're going to be talking about when it comes to Python is a term that can be a little bit confusing. So let's jump to the class here, right? If you go to the help file and we go to who dot, and what we're looking for is parm template group. Okay, so who dot parm template group. This class is sort of the root of where we're going to start working with parameters. Okay, so not even the who.parm, that is sort of looking at an individual parameter. But when we work with parameters, like literally, forget Python for a second. When you work with parameters, what do? Okay, if I say to you, take this node and go add a node, or add a parameter, like we just did, we went and added that parm. What did we actually do? We went and opened up a big sort of interface here, right? Where we have our list of parameters, like I said before. There is a list. There is a list of potential templates, and then a list of properties for those individual parameters that we have decided to add to our list. Now, this list here in the middle is called a parm template group. Okay, so don't let the sort of the very long and complicated name kind of confuse you. What this is referring to is the group of parameters that form the sort of all the parameters on this parameter sheet. Okay, so they exist on normal nodes, but obviously with spare parameters and stuff. So each node has a list of parameters, but then each HDA has a list of parameters too. And obviously when we first create an instance of that HDA, it's perfect. Sort of like with humans, when you have a baby, it's normally so, you know, absolutely perfect. And then later on, you might get, you know, blemishes on your skin, get scars, you could, you know, change your hair color, but at first, it's sort of more perfect, right? So yes, you can drop down an HDA, and then you can add additional things to it, or you can even go and remove certain parameters. But you know, and that is altering its actual, sorry, not through this one, the edit parameter interface. We can now go in through here and actually add things in here, or we could remove this one. But the definition over here also has its own parameter template group, okay, parm template group. Okay, so let's take a look at this class now and sort of see what we can do with this, right? So I kind of want you to, I sort of want to talk you through how this works when we're doing it manually, and then we're going to recreate that using Python. Okay, now I hope you're all still following here. If not, you're going to maybe need to repeat this lesson because it can get a bit hairy, and I'm trying my best to sort of keep all of it in a row, right? So if we were to add a parameter, we come to this list, our parm template group. We search through a list of templates, which are called parm templates, not parm template groups. So there are two separate things. There are who.parm template group class, which is this middle section, and then there is a list of who.parm template objects. Okay, which is another class, and this is this list on the left. Okay, so we essentially choose one of these and add it in to our group. Okay, so let's go and do another one. We'll grab a string and we add it in. We choose the parameters of this this new parameter that we've added in. So we choose the settings. We set a name. So my string, we set a label, which can be whatever we want. We can change certain things, maybe the size of it, set the default, switch on the menu, or do anything we want over here. Maybe make it horizontally join to the next parameter, something, whatever. We customize this to do what we want. But I want to point out something, is that I've already dragged this string in here. But in this list of parameters over here in this interface, the string has not appeared yet. Okay, it is only sort of committed and actually appears and is built when we click apply here, right? So I essentially have kind of like although this is the list of parameters on our node, it's kind of copied. It's almost like when we worked with frozen geometry versus live geometry. This is not live. It didn't, as I dragged it in, appear in our list here. It appears in this list in the middle, and only when I click accept does it then change the actual node itself. Very similar to what is going to happen in Python. We're going to work with a copy construct the theoretical kind of plan of what we would like our parameters to look like, and then we're going to commit it to the node. Okay, so it's very different to like when we create a node, it immediately, instantly creates a node. With parameters, we create these kind of floating, invisible, theoretical parameters, assemble them all into a big, invisible, theoretical group of parameters called a PaLM template group. And then we attach that PaLM template group to a node, right? And what it essentially does is replaces the entire parameter interface with that group that we've told it to take on. Okay, so everything we just did, going here, adding a template, setting it up, adding it into here, choosing where it goes, putting it into a folder or whatever, and clicking accept, is exactly what we're going to do in Python. And the exact same process happens here on the HDA. You can still select from the same things. We can still add it in, still customize it, and then when we accept, then what it does is it actually adds it into the HDA itself, right? So it alters the original plan for test dummy. So now when I drop down a new one, it comes with that string. Okay. All right. So I hope you're following up to this point, because now is when it sort of starts getting a little bit more complicated. All right. So let's examine this who.PaLM template group class and see what we can do to it. Okay, keeping in mind that what it essentially is this list. Okay, so there's a whole big explanation in the beginning here. You can read through it. In fact, I do recommend that you do read this, but if it starts getting confusing, just don't worry. Maybe skip past it, go back to it later on, read little bits of it, because sometimes I actually find bits of this more confusing. You know, you think you're just slightly confused. You start reading their explanation of it, and it just goes down this deep, dark rabbit hole, and you're like, whoa, hang on, how does this work again? So I'm going to try and show you the simplest way to work with this, and then maybe when you do understand it and have a working knowledge of how to actually manipulate these parameters, then when you read this explanation that they give, it'll make a little bit more sense. Okay. Right. So what we can do with our PaLM template group, well, the first thing we're going to want to be able to do is get our PaLM template group. Remember that all coding essentially comes down to getting certain data, manipulating that data, and then setting certain data. Whether we set that same data, so in other words we overwrite, or whether we sort of take the data, manipulate, and then create a new piece of data. So sort of save it as something new and unique. Okay. So the first step is to be able to get data. In other words, I want to be able to fetch the list of parameters that a node already has, or the list of parameters that an HDA already has, right? And those are two different things. So this is actually where the main difference is between HDAs and normal nodes. Once we've fetched that parameter template group, then it's kind of the same. From that point onwards, we are going to manipulate the list of parameters that we want, set the settings, get it all looking right, and then when we set it, then it'll also be different again. So just the getting and the setting are different when we're working with HDAs and normal nodes, but the manipulating in the middle is basically the same. Okay, so the way to fetch the PaLM template group from our nodes is not done through the PaLM template group. So it doesn't have a function to go and just fetch it, right? Very similar to sort of how to get parameters and stuff. You need to reference a node in order to get the parameters off of it, and you need to reference the parameter to get the values from it. There's kind of a hierarchy of data, okay? So what we're going to do to grab the PaLM template group off of a node, we're going to start with the simplest one, which is a normal node. In fact, I'm going to open my Python source editor because I think it's going to be easier to work with this. Okay, so I'm going to compress my little nodes to the bottom here, and we've got a Python shell. Okay, so we can see everything. Right. So let's grab a reference to our node. So I'm just going to pull this in, I'm going to say n equals. Okay, so n equals who.node, and we've got a reference to our node. Now on our who.node class, let's call it up here, who.node class, we have a function that can grab our parm template group. So let's search for the word parm, and you're going to see in this list is a here we go, parm template group. Okay, so this returns the group of parm templates corresponding for the current parameter layout. Okay, and see here it says returns who.parm template group. So this is our way of grabbing the parm template group from the node. We reference the node first, then we grab the group. Once we've got the group, we then enter into the actual group over here and can apply these functions to it. Right? So I'm going to say group equals, I'm just going to call it group, or you can call it whatever you want. And I'm going to say n.parm template group. Okay, and it takes no arguments, it just fetches the group. Now, it's important to understand that there is only one parm template group on a node at a time. So a node has a set of parameters. It doesn't have multiple that are somehow combined or added to one another or whatever. It just has one. So you can we can make alterations to this, and then we replace the sort of parameter template list with another entire list. Okay. So let's print our group over here. So when we say, so we fetched our node, we fetched our parm template group, and we print this group, we now have a Python object, which is a who.parm template group. And on this, we can apply all of those functions. So now we'll be able to actually list our parameters and start altering this. Okay. Now on an HDA, it's a very similar process, except don't forget that HDAs do not live in our scene. They live on disk. So instead of referencing a node like this, we have to reference the HDA itself. Okay. Now what we can do, a way to find an HDA is actually through the who.node class. We can grab, if the node that we have referred to is an HDA, then there is a function that allows us to go from the node and find its HDA, right? Now, if we search in here for something like HDA, I mean, here there's a function to create a digital asset. We can grab the HDA module, but you'll see there's nothing to just grab the actual HDA definition. Instead, what we have to do is grab the node type, right? That's because we don't care about the actual node itself. Remember, we're not talking about, Dave, the actual human. We're talking about humans themselves. So we want to look at the fact that Dave is a human, not just himself, right? So we want to grab the type. So this grabs just the node and grabs the template group. So that grabs the spare parameters from the top. Here we're going to take n equals, and then I'm going to feed it this new node instead. So I'm going to say n equals, and I'm going to feed it this node. Now on that node, if we go n dot type, well, that returns the node's type. Okay, I'm just going to call it t, right? Because I think type is an actual function, so I don't want to call it. I don't want to override the function. So I'm just going to say type equals. Okay. So now what we can do is print. I'm going to just kill this for now. I'm going to print t, right? So now, instead of printing just n is a reference to our actual node. So if I rename this node to something weird and then print, okay, well, hang on, let's call it that, right? So when I print n, it prints the name of our node, and it has a reference to literally this exact node. But when I print t, that's referring to the node type, which is a node type for object test dummy. Okay, so this is its own unique type, the same way that this is a geo node, this is a test dummy node. Okay, and now, instead of just referring to that type itself, we want to refer to the actual blueprint, the template that defines this type. Okay. So now instead of we're looking beyond just saying, oh, well, let's refer to human beings in general, we're saying now let's look at the actual sort of genetic structure of human beings. Okay. So there is one more step that we have to do here, which is to take type.definition. All right. So you'll see that if we follow the who.nodeType class over here, then inside of here is a function called definition, which returns a who.hdadefinition class, right? So this is the way that we can then get to our actual definition, but from our node. Okay. So now there's a who.hdadefinition class, and you'll see that on this class, the same way that on our nodes, on our who.node class, we have palm template group. Okay, if I go to palm, there we go. Wait, where is it? There. Palm template group exists on who.node class. Well, it also exists on the who.hdadefinition class. Okay, palm template group. Same function, exact same function, and it still returns the same thing, who.palm template group, which is what we're after. We're trying to get to this group, this class, so that we can use the methods that exist on that class. But we have to just go a much deeper way to get there with HDAs, because we're not wanting to manipulate the template group on the node itself. We want to take the node, we want to go to its type, then we go to its definition, and then on that definition, we search for the palm template group. So now we would say group equals d.palm template group. And now when we print group, we will also get the same thing. Okay, we're printing a palm template group. Okay, so that may seem like the same thing, but on our normal node, we can only do the first method. We can take node.palm template group, and it returns the palm template group. Okay, we cannot do it on, we cannot go node.type.definition.palm template group, because that is going to fail, because we have no definition for a node that is not published. Whereas on an HDA, we can do both of these methods, and that is where it gets a little confusing, is you need to make sure you're doing it to the right one. If you want to add a spare parameter and not alter the actual definition of the HDA itself, then you need to refer to exactly what we just did here. You refer to this node.palm template group. Okay, and that will alter its spare parameters. If we want to go and actually alter the template, the blueprint for all examples of a test dummy node, then we go deeper and we go to, well, we can drag this node in and we refer to the node.type.definition.palm template group. And then we will return a different palm template group, even though it may look like the same here. And if it's a fresh HDA that's just been dropped down, then its blueprint will be the same as its actual current version. Like I said, with a newborn baby, it's sort of genetically perfect, right? And nothing has been altered. But then later on, we can add spare parameters, and then our palm template group that comes from just running node.palm template group is a very different thing to going through the type, the definition, and then to the palm template group. Okay. So essentially this one over here is going to type properties, and it's this list. If we go here, and now we add some more parameters to here, let's maybe drag in a float, and in fact I'll duplicate it a few times, so there's a few extra floats on the top here. These will only appear if we search for the node palm template group, but not the type definition group. Okay. All right, so that's a bit bit of a mouthful, but I hope that sort of makes sense, right? If not, maybe it'll start to make sense just now as we move forward with this. But again, repeat this lesson as many times as you need to, because this can be a bit crazy. Now, I just want to point out that we can also, if we need to, it's not always that common, but it is possible to create a brand new Palm template group. What we're doing now is getting data. So we're fetching it from a certain existing node already that already comes with parameters. But this Palm template group that we fetched here is a theoretical list. Remember, I said the same way that when we open this up and we can manipulate this list, so I can go and delete these parameters. They haven't removed themselves from here until I click apply. That's because this list here is kind of theoretical until I actually commit this, and then it makes the change. So the same thing is happening here. These Palm template group, I can manipulate this, add parameters, remove parameters, change things, clear it, empty it, but only when I actually attach it to a node does it apply those changes to that node. So in that same sort of theory, we could create a blank list of parameters, an empty list, then add a bunch of parameters that we want, and then just go and attach it to a node. Okay, so we don't have to start by fetching from a node. So let's do that. Now with this, it's very simple. Under the who.palm template group class, it has a constructor. Okay, so it has an init function, and this init magic method over here allows us to literally just generate a Palm template group. Okay, now there are two ways of doing it. It will accept a list of Palm templates, which are actual list of float and string and whatever. Okay, so we're going to get to talking about Palm templates next lesson. But you don't even have to give it a list of actual Palm templates. We can just start with an empty one. And that's because you see here it has by default, it accepts an empty list. And then it will create just an empty Palm template group. So let's do that over here. If we just say group equals, and whenever there's a constructor, whenever there's an init function, that means that we can just call the actual class itself. And when you call the class, it creates an instance of itself. Remember, there is no constructor for who.node, so you can't do that. Well, in this case, there is an init, which means we can. So we go who.palm template group, and we just call the class. So calling means putting these round brackets. Okay. Now we could feed it a list of Palm templates in here, but we haven't created any, so we're just wanting an empty Palm template group. And now when we say print group, then you'll see over here it does indeed print a group. When I click apply, you see it prints Palm template group. Right? Now, obviously this instance of a Palm template group is very different to this one, which is very different to this one, because they have their own list of parameters in it. But it's still the same type of object. Okay, so that's an empty one, or we could feed it a list and it'll still create a brand new floating Palm template group. Okay. Now, what happens when we're done manipulating? Okay, and we're going to actually talk about, it's kind of strange now, we're talking about creating one and getting data. Then normally we do manipulating and then we set. But I'm going to talk about setting in this lesson, because the entire of next lesson is going to be dedicated to just the middle bit, the manipulating of parameters. Okay, so in this case, I'm just going to assume that we have the Palm template group that we want. And we just, once we've fetched it, we just want to set it again. Okay, so it's very similar to what we just did, with the exact same distinction that it's different on a normal node compared to an HDA. Okay, and we do it basically in exactly the same way, except instead of using the Palm template group function, we would use set Palm template group. Okay, so let's do that as an example. So we go to our normal node. So let's grab a reference to our node, and we say n equals, and then we've got our node. Now what we're going to do is say on node, so on the node class, let's check in, where was our node class? Here it is. Let's look in our list, and there should be one set palm template group. So just under palm template group. Okay. So palm template group requires no arguments because it's just going to fetch the one and only palm template group that exists there. But this one does require us to actually feed it a palm template group. Remember, this is essentially a theoretical plan of what parameters should be on this node. We're saying, look at that plan and make sure that your parameters now match this group, okay, this template. And then there is just an additional extra thing, rename conflicting palms. Okay, so that will then sort of say if there are already parameters on it that are conflicting with sort of names, because they have to be unique names, then it will rename those. Okay, but by default that's false. Okay, so this set palm template group is what we're looking for. It exists on who.node, and exactly the same way it exists on who.hda definition. Okay, so on a normal parameter, when we want to set its actual parameters on the top level, we just go n.set palm template group. Oops. Set palm template group there, and then we need to just feed it a group. So we could feed it any group. For example, remember we just created an empty group. Well, let's go and do that. That'll actually be a nice sort of easy way to show you what we're talking about here. So I'm going to say group equals, and we're just going to create an empty palm template group. So who.palm template group, no arguments, so it's an empty group. And then when we say node.set palm template group and feed it this group, what we're essentially saying is, it's kind of like going here, but imagine if this list was empty. There was nothing in the middle here. This was all empty. And now it's like taking that empty list and attaching it to this node. Okay. So when we click apply, then it empties itself. Now, you'll notice that it didn't quite empty itself entirely. And that's because GeoNodes intrinsically have these parameters that cannot be removed from them. You'll see that they're even grayed out. Okay, so it is impossible to remove everything from a GeoNode. All right, we could do the same thing though on a subnet. Let's take a subnet and have a look at what. Okay, these are also locked, so we're kind of limited with certain things. You can't actually go and empty everything. But you see, if we drop down a blank GeoNode, that there are certain extra parameters, like under render, for example. Look at all of these. Okay, so these exist here. But when we come under here, under render, you see there's only 2 parameters left. Well, actually 3. So when we go here, we'll see that those 3 are locked, but the rest were not. These ones were not. Okay. So by applying an empty palm template group, it overwrote it with everything that could be overwritten, and only the things that were intrinsic in Houdini that cannot be overwritten with nothing were left behind. Okay, so let's now do the same thing with our HDA. Okay, so on our HDA, exact same method, except that we just need to go a little bit deeper, because if we do it to the surface of the node, then we're only going to manipulate this instance of that node. So let's do that. If I drag it in here, a reference to this node, even though it's an HDA, doesn't matter. Okay, because it's actually only an instance of an HDA. I take my node, I create an empty group, and I set that group to be equal to the palm template group on my node. So what's going to happen now? When I click apply, then on my test dummy, okay, basically it will have done nothing, because all of these parameters that were on the node already have been locked. See, unlike on a GeoNode here, where some things weren't locked, like let's go to this brand new GeoNode, you'll see these were not locked. Once we published this, okay, once we created a digital asset out of this, then these parameters that were unlocked, move over from being spare parameters on a geo node to actually being part of the HDA. So when we go here to our edit PARM interface, all of these are locked and therefore nothing can be overwritten. When we go to our type properties and have a look through here, now we can see that these are ungrayed. So if we alter the HDA, then we can remove these parameters if we want to. Still though, we cannot ever remove things like translate, rotate, scale, all of these ones that are locked. Okay, these are intrinsic and cannot ever be removed. Okay, so in order to manipulate that, we're going to have to go and alter the HDA definition. Remember, if we had gone in here and maybe created those floats like we did earlier, then yes, we'd have those floats. When we override our PARM template group on our node with an empty one, then when we click apply, you'll see those disappear. So now let's go to the actual HDA definition and override it with an empty group. Okay, so we still reference our node the same, but then we just go, I'm just going to grab D equals, or I'm actually just going to call it definition so that it's a little bit more explicit. So we don't have to literally store our type in a variable and then store our definition in a variable. We can kind of do them in one go, which is normally what I do. So I go to the node reference and then I say type.definition. So node.type.definition is going to return our definition, and we're storing that in a variable called definition. Then we create an empty group with no parameters in it. And then instead of going node.setPalmTemplateGroup, we set the Palm template group on the definition. So remember, if we go into here under our HDA definition class, which is what this is, then we have a set Palm template group function as well. And it's the exact same function, except here it has an additional argument to create a backup. Okay, so create a backup is true. So every time we save this node, it's going to actually create a backup somewhere, which means that if we've accidentally manipulated this in a way that we didn't expect, we can go back to our backup. Okay, so if I just swap this in for definition, what I'm saying is go to that node definition. In other words, go to the file. See here under type properties, this file is what we're manipulating, not the node. So it says go to this file, the definition, and change the Palm template group and set it to be equal to this empty one. So now when we click apply, what has happened? On our HDA, we will have nothing left except the parameters that could not be manipulated. That custom string that we created has disappeared, as well as everything else under the render parameter, under the render folder, everything that was not intrinsic. Okay, and obviously now if we drop down another test dummy, it will also have the exact same Palm template group because it's coming from that definition on file. There's one definition, and all the instances of that HDA come from that same definition. Okay, so what we can actually do in this case, for example, is we could go and, let's say, add some parameters to one node, and then we can essentially copy the entire list of parameters, so the Palm template group, from one node to another if we want to do that. Okay, so let's go and do a few things here. We'll create a folder, we'll throw an integer into it, we'll throw in a float, and maybe we'll give it a label over there and a toggle. Okay, well, yeah, we'll put the toggle on top. Okay, so we've got a few things going on here, right? Now, if we take the Palm template group from this node, store it, and then set it as the Palm template group of another node, then it's going to change that Palm template group. But again, let's keep in mind which one we're actually altering. For example, are we grabbing the Palm template group from the actual definition? Because this definition, see, I just added spare parameters. When I clicked on this this over here, I went to edit parameter interface and created some parameters. So these are spare palms. These live only in my node.type.definition node.palm template group. Okay, they live in that one. They do not live in the node.type.definition.palm template group. Okay, so if I grab the wrong one, then I'm not going to grab the right parameters. And then it's also important to remember which one we're setting. On a normal node, there is only one to set because it has no node.type.definition.palm template group. It only has the node.palm template group. But we could do it the other way. We could take maybe from one HDA and set it on another HDA. Now, which one do we set? Do we want to change the actual HDA definition, or do we want to change just the spare parameters on the surface of that one instance of an HDA? So whichever one we want, it is possible. We just need to make sure we do the right thing. So for example, let's take our HDA here. We're going to grab our first what we're going to do is actually grab our definition palm template group and set it to be equal to the one on here. Okay, so if I come to this, we've got a reference to that node already over here. So we've got node, and then we've got definition equals node.type.definition. Then our group, instead of creating an empty one, we're going to grab it from this definition. So we're going to say definition dot palm template group. So essentially what we've done is node.type.definition.palm template group, stored that as a variable called group, and now we're going to go to not our definition, we're actually going to go to this node. Okay, so I'm going to create another reference over here. I'm just going to call it node 2, and we're going to grab a reference to that node. Okay, now if I say node 2.set palm template group, what I'm doing is I'm changing the spare parameters on node 2 to be equal to the type definition palm template group of this. Okay, now when I click apply, okay, you can't really see anything because they actually had the same. So let's actually change that to this node instead. Instead of referencing node, let's reference Geo1, because remember, Geo1 is unaltered. It actually has all of its all of these non-intrinsic parameters. It's still got a shading folder, it's still got a sampling folder. Okay, it's got all of these things under the render folder. Okay, so if we take this one's definition, which has none of those things, the render folder only has 3 things in it, we fetch that, which is what we're doing here, and then we set it to be equal to the spare parameters on node 2. Okay, so node 2's spare parameters should now be the same as the definition palm template group of this HDA. When we click apply, then we click on Geo1, we see that it has done exactly that. Okay, and then in fact, if we went to the definition, so let's open up the definition and even add some things. Okay, so we're going to add a folder here. Let's add an integer there and say accept. Okay, and destroy all spare parameters. So now on here, these new things that I've added have been added to the actual HDA themselves, not on here. On the edit palm interface, you'll see these are locked because they are not part of this, right? So if I now go to that same definition, and it doesn't matter, I want to point out here, it does not matter which one of these 2 nodes I grab to get to the definition, because they're both instances of the same HDA, which is test dummy. So that's a test dummy, this is a test dummy. Doesn't matter which node I reference, as long as it is an instance of test dummy. Then when I do type.definition, it's going to grab type is going to be test dummy, definition is going to be the path to the HDA file, and then I'm going to grab the palm template group from that, which is stored on disk, and set it to be equal to, well, set node 2's actual node palms to be equal to the one that's on disk. So when I click apply, you'll see that this folder and integer now appears on this node. Okay, but it appears as a spare parameter. So it appears in here not as an HDA parameter. So if I drop down GeoNode, it will not suddenly now have a folder with some integers in it. Okay, we have not altered its actual definition, we've only altered this individual instance. Okay, now again, let's go, remember, okay, I clicked destroy all spare parameters, so it actually would have cleared out all the spare palms from this one, but we'll go and create a few. So I have not clicked type properties, but instead I've gone under edit parameter interface on our HDA. So yes, we're altering our HDA, but we're altering the HDA node, and we're creating spare parameters on the top here. So I'll create a few, maybe I'll create a file node there or something. So we've got a few spare parameters on this HDA. It lives on this HDA and not on this one. This one is exactly the same as it should be. This one has had alterations done. Okay, it's had some work done. Okay, it's had a nose job. So this one, if we grab its HDA definition, we'll still be grabbing exactly this, right? So you see we're referencing this node, D, F, G, F, D, G, G. Okay, we're referencing this. We're grabbing its type definition, grabbing its PALM template group, and then setting node 2 to be equal to that. So when I click apply, Geo1 does not have that new folder, does not have these two. Why? It's because those are spare parameters, and here I am not fetching those spare parameters. Okay, but if I change this and now went, the group is just equal to n.palm template group. So in other words, I'm not using this line, I'm not using the definition, I'm going to the node, and on the node I'm grabbing the PALM template group. That means I'm grabbing my spare parameters, and then I'm setting Geo1's PALM template group to be that same group. Then when I click apply on Geo1, I now have those folders and float, and then this as well on the top. Okay. All right. So I know that's a lot to take in. There's lots of different ways we can manipulate this, but in the next lesson as well, what we're going to do is actually start manipulating this and creating our own parameter templates and sort of, assembling it all and then saving it on a node, and then you'll see how it all works. But I hope that at least helps clear up some of the mystery behind how to create parameters, because unfortunately it's not as easy as just creating a node. You can't just say, just point to a node and say create PALM. Okay, there is no such thing. You have to grab the PALM template group, create parameters inside of that, then set that group as the new PALM template group. Okay, it's kind of like the movie Face Off. Like we're really literally taking the face off of this node. We're altering it, or maybe swapping it out from another node or doing something, and then sticking the whole thing back on. All right. You cannot just alter the eye color while they're on. You have to like literally take it all off, work on a sort of a template, a plan, and then stick that entire thing back on top of the node. Okay. All right, so thank you everyone, and I'll see you in the next lesson where we then talk about the PALM template class, where we can actually create individual parameters instead of having to manually do them. All right, I'll see you then.